Hello, everyone, and welcome to our math session this morning. This recording is for Wednesday, March 25th, 2020, and we are going to be talking about linear relationships today. So I have a link here on the board for you. I'll share that with you where I share this recording link. Let's get started. Today we are going to be reviewing slope and rate of change, so that we can represent and connect linear relationships. And we'll know if we got it if we can successfully represent a real-world situation on a graph. So we are going to be on page 6 of our STAR math review packet. And let's take a look. It says, what is the unit rate of Williams' road trip? Question 2 says, what is the slope of the line that represents Williams' road trip? And 3 says, what conclusion can be made about the unit rate of Williams' trip and the slope of the line? So press pause and then resume the recording whenever you are ready. Okay, so if we will see here, let me grab a highlighter. The unit rate, remember the unit rate is where our denominator is 1. So we're talking about the miles per hour for 1 hour. So I looked over here at my graph and I see where we have a time of 1 hour. And then I'm going to go up there and I'm looking at Williams' road trip and I see he is going 60 miles per hour at 1 hour. Okay, what is the slope of the line that represents Williams' road trip? So the cool thing is that slope and unit rate are the same. You can also pick 2 points on the line and do your rise over run, where your rise here would be 60 and your run would be 1. So 60 over 1 is 60. So number 3, what conclusion can be made about the unit rate of Williams' trip and the slope of the line? And that's what we just said before, that unit rate and slope are the same thing on a graph. Okay. So let's find the slope and y-intercept of the graph below. So press pause. Workout number 1, and then on number 2, it says the following table shows the relationship between flour and milk in a spice cake recipe. Find the rate of change of the table. So work out both of these by pressing pause and then press play to resume the recording whenever you're ready. Okay, so let's take a look. So here, the rise over run, our slope is rise over run. So our rise is 3, our run is 4. So our rise is 3, run is 4, our slope is 3/4. And then the y-intercept is where it crosses that y-axis. So it crosses the y-axis at -3. Then number 2, the rate of change. So you're finding the change over our y over the change over our x. So from 8 to 10, the change here is 2. From 5 to 7, the change here is also 2. So 2 over 2 gives us a rate of change of 1. To look at our interim questions over this topic, this was question number 1. It says Oscar buys his lunch in the school cafeteria. The cost of 15 school lunches is $33.75. Which graph has a slope that best represents the average cost of the lunches in dollars per lunch? So just go ahead and work this problem out like you were working on it at this time. You may or may not remember what you chose on the interim, but press pause and pick the answer that you think is correct. And the answer is A. Okay, so let's take a look. It says Oscar buys his lunch in the school cafeteria. The cost of 15 lunches It's $33.75. Okay, so the part that is difficult about this question is 15 lunches is not on the graph. It only goes up to 9 lunches. So what did you guys do? How do you think what did you do to solve here for maybe one lunch? That's right. And so what you need to do is you need to divide. You need to find the cost of one lunch. So $33.75, you divide that by 15, and you get $2.25 per lunch. And so once you have that amount, then you can see that for one lunch it's $2.25, for 2 lunches it's $2.50, for 3 lunches that would be not for one lunch that would be $2.25, for 2 lunches that would be $4.50, for 3 lunches that would be $6.75, and so forth. And so you'll see that graph A represents this relationship. So we divided there to find our unit rate, which is also our slope, and that's how you put that graph on there when the graph does not go as far as 15 lunches. This was question number 19 from the interim. It said a bottle contains 30 fluid ounces of orange juice and 18 fluid ounces of pineapple juice. Which graph has a slope that best represents the ratio of orange juice to pineapple juice in this bottle? So go ahead and press pause and work this one out the same way we did the last one. All right, the answer here is B. So 30 fluid ounces of orange juice. Orange juice is on the right side, or sorry, on the y-axis, and the pineapple juice is down here on the x-axis. So you're looking for the one that has 18. Now 18 is not on there again. So we are going to do 30 divided by 18. And I'm working that out now. And so that would be for every 1 ounce of pineapple juice, there's about 1.67 ounces of orange juice. So for 2 ounces of pineapple juice, like here, the graph is going by 2, so it's a little bit harder to see that unit rate. So for 2, that would be about 3.3, so a little bit less than 4. And so graph G goes along with this relationship. All right, then this was question number 32 from the interim. It says the table shows the linear relationship between the number of hours Francis worked, X, and the amount of money Francis earned, Y. Based on the table, how much did Francis earn per hour? So press pause, work this one out. All right, and the answer here is B. Don't let this confuse you when we're talking about a decimal. If this said 2 hours here instead of 1.25, we would do 1750 divided by 2. So just because it's a decimal number, not a whole number, you're still going to do the same thing. You will do 1750 divided by 1.25, and that gives you $14 per hour. All right, guys, that's all that I have for you today for this lesson. Awesome job with linear relationships. Today we looked at using data from a table or graph to determine the rate of change or slope and the y-intercept in mathematical and real-world problems. We looked at how to interpret the unit rate as the slope of the line that graphs the relationship, that models the relationship on a graph. So great job. I will be sending one more recording for tomorrow, Thursday, March 26th. If you have any questions or need any help with anything whatsoever, be sure to send me an email. I know it's kind of crazy right now, but I am happy to help you at any time in any way that I can.